Welcome to another episode of Code for Thought. During this season of Code for Thought, I want to take a look at efforts to keep track of all the research, source code, software applications and libraries that are out there. And in this first episode on the subject, we'll be going to Paris in France to meet with Morane Gruenpeter and Benoît Chauvet from the Software Heritage Institute. But before we do that, let's talk about why we should track research software at all. Research and research output is increasingly relying on software applications and libraries. And since there's a huge number of research projects, even for one university or research center, there's a risk of duplication, or shall we say reinventing the wheel. And also, since software produces data used in research output, it's important that these results can be reproduced and verified, which kind of implies you're able to access and run the software. And so a first step is to find software projects and list them. And after all, one of the four principles of FAIR is, well, findable. But that's easier said than done. For one, not every project is stored in source code repositories, making it hard for anyone to know where they are and how to access them. But even with the projects in repositories such as Bitbucket, GitLab or GitHub, things may not be quite as findable as you think. Research centers and universities have been grappling with this for some time, and from this essentially two solutions emerged. The first is what you might call a research software directory. The directory would list available software, but only as a link to the actual location of the software together with some descriptive metadata that help you find it. The second is an actual software archive, which stores the actual source code together with the appropriate documentation and descriptions, and provides a service to find and trace projects. Later this season, we will hear from research software directories, the first option, such as from the eScience Center in the Netherlands and Helmholtz in Germany. But in this episode, I want to focus on archiving and preserving the actual source code, which brings us back to software heritage. The Institute was founded end of June 2016 and is headed by Roberto Di Cosmo. Software Heritage is backed by the National Institute for Research and Technology, called INRIA, in France, and in fact the actual offices are in an INRIA building in Paris, which is where I met with Morane and Benoit. In our meeting we discussed the work Software Heritage does. But now over to Morane, who will take us through Software Heritage, its mission and what it tries to accomplish. And here she is.
Thank you, Peter, and thank you for inviting me to talk on your podcast. So my name is Morane Gruenpeter, and I'm a software engineer and metadata specialist, a project manager. I have many hats in the Software Heritage project, but actually I've started not as a software engineer, I've started as a musician, my career path, and I've become a software engineer when arriving in Paris in 2011. And for my master's degree in software engineering, I've took an internship at Software Heritage as to work on the metadata challenge, building the semantic web of free and open source software. So it was a big challenge. And I continued on the project to work on different aspects of software heritage, of archiving software, and especially archiving metadata describing software.
And I'm quite excited about the fact that you're a musician as well. What kind of instruments did you?
Harp. I am a harpist, yes.
Do you still play?
I do still play, but much less than before when I was professional and in an orchestra, and that's another lifetime.
Indeed, a very exciting one.
Yes.
You mentioned Software Heritage, so maybe you can introduce what Software Heritage is, the organization, and what it does.
Software Heritage, you can say it's more than just an archive, but it is an archive. It is the universal source code archive with a mission, a very ambitious mission, to collect, preserve, and share all the software source code. Now, at present, we collect public software that's online, so mostly open source. Why I say mostly, because some of the public code online doesn't have a license, so it's not open source, but it's still online and public. The ambitious mission is really to have and hold and preserve all the software commons in this infrastructure called software heritage, catering to academia, but not only to academia, also to industry, public administration, and cultural heritage.
Research software directories often provide links to repositories, but you're actually storing the actual code, aren't you?
Yes, we are, because software source code is fragile. When you store a link, for example, on a directory to a repository on GitHub or on GitLab or on Bitbucket, you may never see this code later on because the link might die, the link might not exist anymore, the project might migrate somewhere else, or the forge might close. That happened in the past with Gitorios, for example, or Google Code. Forges close, and the mission they have is a collaborative development platform. It's not an archive. So Software Hedge comes to resolve this issue by having a place where all the different types of software development system can be really preserved. Why all? Because we try to really be inclusive to any type of development version control system. So we do have the possibility to preserve all the code in a Git version control system, but also in Mercurial and SVN, also packages. This means that you can find in Software Heritage very large amount of code in the same place. So it's also a very large data set.
So what is the history of software heritage? Where does it come from? Where does it start, or where did it start?
That's a good question, because it didn't start long ago. And it's quite surprising. I was surprised to know that only in 2016 was the project announced. I wasn't on the project then. The thoughts about it started before, but it's quite recent for now. Now we are in 2023. It's surprising that it didn't start when software engineering started, like coding in general, because it's so important to preserve this knowledge somewhere. Then it was announced in 2016. At the time, there wasn't a web interface where you can search the code and find software and even save code by yourself. And today we do have nice features like the Save Code Now feature and the Add Forge Now feature. When you identify a forge that's not archived yet in Software Heritage, you can notify the Software Heritage. And there's some other features that came along with this evolution.
So you mentioned that you're not only there for academia, and you're certainly not domain specific. You're not just an archive, say, for biochemistry or physics. You're there for everybody.
Yes.
Which is great, but it's also a challenge. A lot of the industry code, if you want to attract industry, may not be open source. So how do you deal with that, or how can industry partners then interact with software heritage?
Some industry partners do have open source code or do rely on open source code. So they might have dependencies to open source project and want to have this code archived and preserved so we can be sure that it can be accessed later on if there's some problems with the current repositories. For that, we do cater industry. Now, you said that some of the code is not open source, so it's proprietary. That's true, but it's a question of time, because everything that is now closed will be in the future, maybe in a long, long time, will be public domain. We need to keep this in mind and try to find ways to preserve, to keep the software. Even if it's not open today, it will be shared when it is.
I think in France, and please correct me if I'm wrong, but I think in France there's a rule that if you are funded by the state to a certain percentage, then you have to make your code open source.
Yes.
And with that in mind, in particular in research, but also some industries get funded by the state, they will have an obligation to make the code public.
Yes, there is this obligation in France. So I think that France is very avant-garde in that sense that the default is open source. There's a very large open source community, and open source is really appreciated in France also, as we have open source communities, but also from the public administration side, making public administration code also open and public. And I'm very grateful for that. That's a good thing to go with. And so software heritage is catering also public administration by preserving the code that was open by the public administration registries. And this is some of the collaboration that we have to maintain and have a hold of this type of software, which is not academic software or research software.
So in that time, since 2016, software heritage has grown quite a bit. How big is your team at the moment, and how many repositories have you actually, or how many software libraries have you uploaded?
Well, that's many questions in one question.
No.
I will start with the beginning. So I didn't say before, in 2016 when it was announced, there was Roberto Di Cosmo and Stefano Zacchiroli, who are behind the project, CEO and CTO, and they are still here and pushing this project forward. And now with them, we are a larger team. We are 17 people that are full-time on the software heritage mission.
And in terms of repositories,
yes.
and because, I folded 2 questions and 3 questions into one. So let's talk about the growth of your...
So now, in terms of repositories, I've checked before our interview because it's always growing. It's growing every day, every minute. Today we are at 235 million repositories archived and more than 15 billion files. I think that's the stat today. You can always check it if you are interested when you are hearing this podcast on the archive web app, which is at archive.softwareheritage.org. And there's very nice graphs that show you the growth of software heritage. And it's very nice to see how ambitious it is and how we do have so many things in the archive at the moment.
It sounds like a huge challenge. It's very ambitious, and obviously it's a long-term project. Yeah. But what's in store for software heritage this year and beyond?
That's also a very good thing to think about. I don't know if I have the answer to it. What I can say that on the short term, we have a roadmap and have some big things happening, like metadata sharing, because for the moment, most of the items that are visible on the archive are the software artifacts. So you can get to the archive, you find your repository, and you find the code and all the development history, and you can identify it, but the metadata is not visible yet. Why I say yet? Because that's in the future. That's something we are working on to have better search engine, to search the archive, and also to show different sources of metadata that describe the software, which is very important to understand the software. So that's something for the near future. For the further long-term future, well, software heritage is a long-term initiative. We are here to stay and to grow, and also to have a more long-term perspective in terms of stability. There's a very nice aspect of software heritage is that we know that even this infrastructure is fragile. So we do have duplication of the actual archive, and we do want to launch a series of mirror network where the actual archive is mirrored in other institutions. So that if something happens in France or in the INRIA Research Center or anything can happen, we do need to keep the software source code safe.
That's a nice segue into my next set of questions. So first of which is the metadata, because that is really quite challenging, isn't it? So anybody can think that it's easy to create some metadata title for the software, etc. But there are many different repositories. How do you approach creating metadata that meet the requirements to be searchable, findable, and also interact and interoperate with other repositories or other research centers? How do you approach that?
My answer will be a very complex answer to this complex question, because it is the challenge. Metadata can be created differently in different communities, in different domains. You can find metadata in package managers where you create what we call the metadata file, which is an intrinsic file inside the code. And on these files, you will find very few properties that describe the software, but that are very important, have a minimal metadata set. You need other type of metadata to search and to cite software, because you need the authors. The authors is a piece of metadata, but a complex one, because you need to know who is the copyright holder, who are the real authors, who are just contributors, what are their roles. And these properties can be defined or specified in different types of files inside the code, or even in a registry outside the code. So you have different registries that will want to hold this type of information. And then us, Software Heritage, we need to find a way to clean up the mess, because there will be metadata from many resources in different vocabularies, in different ontologies. We found a project a few years ago called Code Meta. I'm not sure if you have heard about Code Meta, but Code Meta is a subset of the schema.org source code and software application classes. In that sense, it's not inventing a new vocabulary, and yet there are some new properties that cater specifically research software in the Code Meta vocabulary. More than that, the Code Meta vocabulary has a crosswalk table mapping different vocabularies to Code Meta. And we found this very interesting because then we are using it, Software Heritage is using it to index intrinsic metadata that we find in the software to this agreed upon vocabulary to have everything with the same vocabulary. And that's cleaning it a little bit, but not everything, because we also have different metadata resources outside the software. For example, if you have a Wikidata page for a software project, or in a registry, and you can have for the same software a registry record in one place and another place. You might have the same metadata or different metadata. So it's really a big challenge, the metadata challenge, and we are trying to move forward and find solutions to this in terms of infrastructure and also in terms of community. So one of the activities I'm leading on the Fair Impact project, so that's an European project leading some initiative towards a more fair ecosystem, more fair in terms of findable, accessible, interoperable, and reusable. And in this project, one of the deliverables is the research software metadata guidelines to help researchers when they want to describe their software, the research software, in the best possible way, so that this metadata is captured, collected, and curated, and then also archived and can be used in indexing and search engines.
So you're actually working also with many different organizations then. Could you name perhaps some of them that you're working with at the moment?
Yes, of course, I can name a lot. Let's keep it the short list. So this was what I've just mentioned was the Fair Impact project, on which we are working with the SSI, the Software Sustainability Institute. We're working with UPM and Uniman. I'm not sure if I need to open up all the different acronyms, but these are part of the partners that are on this specific task to define the research software metadata guidelines. Software Heritage is working with many partners also on a feature called the deposit feature, because most of the software that Software Heritage holds is a pool software. What do I mean when I say that? We collect it actively. People do not push the software to Software Heritage, but Software Heritage goes into the internet and gets all this software inside. With the deposit feature, we have specific partnerships with actors in academia that push the software into Software Heritage to guarantee the preservation of the software and of the metadata. So we have that in place with the HAL, French National Archive, which is written HAL. We have that with eLife journal, also for publication, where publication have software submitted with the publication. And with IPOL, also a publisher for image processing online. And we're working at the moment through another European project called FairCore for EOSC don't get lost in the acronyms. And there we are working with the CERN to connect in Benoît RDM, which is behind Zenodo, to software heritage as well. The idea would be to have infrastructure interoperable between the scholarly infrastructure, so scholarly repositories, and software heritage. So here with CERN, it's an example, but we want to do it also with Dataverse. And we're working on that with Dagstuhl and Episciences, which are also publisher. It would be nice if many publishers would submit the code and archive it into software heritage.
I'm glad you also mentioned Zenodo. And it's also encouraging to see that publishers are getting on board, because that has always been a classical problem, that publishers focus on the text rather than the software. But you see that changing now.
Yes, I see that changing. Well, it depends on the publisher, because we're talking about 4 publishers and and there are so many publishers out there. I think it really depends on many different aspects in the change that is coming into place recently, making software a first-class output in this ecosystem. It's not there yet. Publishers, and we do want to get publishers on board, and more than that, institutions on board, because sometimes you hear that researchers develop software but are not recognized for all the effort they are putting into software, into open source software. This is something we would like to see changing in the coming years. I witnessed this beginning of the change because I arrived at Software Heritage in 2017, and at the time, software was really not considered at all. And it became recently in 2020 a hot topic, Fair for Research Software and other big initiatives. And RISA has also had a large part in that, making software more visible as an equal to publications and data.
Well, thank you very much for your time, Morane. It was a very interesting and very thrilling talk. And I look forward to seeing more from Software Heritage in the future.
Thank you, Peter.
After I met with Morane, I had a chance to talk to Benoît for a few minutes. Benoît manages engineering teams at Software Heritage, and we discussed some of the technical challenges they face. Here's Benoît. Hello, Benoît.
Hello.
Maybe you can introduce yourself quickly.
Sure. So I'm Benoît Chauvet. I'm a software engineering manager for Software Heritage. I joined the team in March 2022. My job consists in coordinating all the tasks of the engineering team, so which is split in 2 parts, which are development and sysadmin.
2022, that was almost during the pandemic then, when you joined?
Yes, it was just at the end of the pandemic. Part of the organization had to deal with the remote work, but the team is pretty much independent, and there is a lot of autonomy, so it was fair enough to manage.
Software Heritage is a huge archive of lots of code. How is it actually organized? How do you maintain it, and how do you allow it to grow?
At the moment, the growth of the archive is a real concern. We are in a phase of switching to a different infrastructure. So historically, the archive was organized around the PostgreSQL database for the graph, so all the model representing the organization of the revisions, the directories, and the origins. And the contents, so the file contents, are still stored in a ZFS archive, ZFS, so it's a file system. We are changing for both of these modules. So the graph storage is switching to a Cassandra database instead of Postgre. And the object storage will be transferred to a Red Hat Ceph-based infrastructure.
That is quite a huge task to do, because you have a huge amount of code already in there. How do you manage that transition? I mean, how long is it going to take, do you think?
The process, I think, is not measured yet, the duration of the migration. The transfer itself, it's quite of a huge volume of data to transfer, but it's something that is measurable. The most important point, I think, is how to deal with new incoming content, how to transfer it and to avoid a cut of service. So we are providing some replayers and some cross replaying. So we could alternatively keep writing in the ZFS file system or in the safe object storage and then cross replicate the data.
So moving away a little bit from the transition, one question that I have was when you store a software application, say somebody is registering it with software heritage, but the software itself depends on other libraries that are not stored in the GitHub repository where the software currently is. How do you manage these dependencies?
For now, we don't have a specific dependency management. We just archive contents and projects. It's actually an open subject, so we are thinking of providing metadata on the archive contents to identify the dependencies. At the moment, I think if we don't have a targeted dependency, we don't have a fallback solution. So maybe we would reference it or try to archive it, but we don't have this concern yet. The purpose of the archive of software heritage is to archive all the source code. So normally we should, on the long term, not be facing this problem. But
it's also up to the person uploading the software. Say my code depends on Python version 3.10 rather than 3. or 4.x in future. The metadata are provided by the people uploading the software.
It depends on the way you archive some content. There are some specific ways of pushing some content, which is not the main way to archive, but we have a feature called deposit, but only a few instances can use the deposit. So then you can deposit some source code and add external metadata using a code meta format, for instance. But for most of the archive process, the normal process, it's rather a pull process. So the archive software heritage gets the content and archives it. So for all these cases, we will try to identify in the source code, in the source file, information regarding the dependencies or so for instance, a pom.xml file or a configuration file. So we can identify the dependencies, exploring the intrinsic metadata.
Okay. Staying with the theme of maintenance a little bit. Software, of course, is a living thing. So people develop software, they upload it to software heritage, but then the code changes at their end. How do you deal with that? Do you have to upload the code or the changes again? How is this being managed?
I think in the case of the deposit, you have to upload again the upgrades of your code because it's not related to a repository, so there is no way for software heritage to visit again. So if you strictly deposit some code, for instance, with the HAL project, which is a platform for all the French research publications, if you just push a tarball or a zip file containing your code, then you will have to deposit again. If you want the archive to revisit and to automatically update, then you have to use other solutions, like for instance, Save Code Now, which is a feature where you just provide the URL of an origin. So software heritage visits it as soon as you provide this origin, and then it is scheduled and it will be regularly visited.
My final question, how people actually go and upload it. I've been to the website, so there is this link, Save Software Now, and there are various different options how you can archive it then.
Yes, so for most people, the most common way to archive code by yourself is to use the Save Code Now feature, where you can archive your one single repo. And if you have an already archived repository, but which is not up to date, so you cannot control when it will be revisited, then you can use the Save Code Now feature to save it again. So you can force it because the Save Code Now feature has been designed in a way that it would be a high priority of processing. For instance, you need to publish a paper, or you can force a new visit using the Save Code Now feature.
At what stage in the project would you recommend people upload their code to a software heritage? Would it be at the beginning of the project, or should they wait until the project is mature enough for it to be uploaded? What would you say?
I would say the sooner the better, because anyway we will start the whole history of a project. So if you upload it later, it's not a problem for us because we will store all the states of the project since its beginning. But once you have archived it once, then it will be visited regularly, so it makes it easier. Otherwise, there is also a policy of archival update. Would be, for instance, each time you create a new release or a new relevant tag, then it's interesting to force a new visit to make sure it is done. And for that, we have implemented solutions about webhooks. For instance, in GitHub, you can implement automatic pushes to the archive, which is actually you force the archive to revisit each time, for instance, you publish a release.
I was about to ask you if you have ways of automating that, because many people have GitHub Actions, for instance, so they could use that to integrate it with their GitHub action.
This is precisely a GitHub action, yes.
Okay.
So yes, I will provide you the links to this, but it exists and it's already in use for some of our users use it actually.
Well, thank you very much for this interesting talk.
You're
and
welcome.
All the best for the future.
Thank you very much, and all the best for you as well.
Well, I hope this episode gave you an overview of what Software Heritage does and tries to accomplish. You can try it out yourself for your own research projects, and in the episode notes you will find the links to the archive and documentation support tools, as well as an API for you to read up on and play with. And with that, good luck! Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya!